Yeah, welcome back to our online classes. If you can recall last week, we talked about solar panel, its type, factors affecting performance of solar panel, and what have you. And as I promised, today we are going to talk about solar charge controller. I remain engineer Abdulmajid Mohamed Salisu from Amaxon Renewable and Engineering Company Limited. What is solar charge controller? Solar charge controller is a device that maintains the state of charge of the battery. It prevents overcharging of the battery. It also prevents over-discharging of the battery. It serves as load controller. What we mean by load controller is just a function inbuilt in the charge controller. It has about 4 functions. Number 1, LVD, LVR, HBD, and HBR. LVD stands for low voltage disconnect, and then LVR, low voltage reconnect, and then HBD, high voltage disconnect, and HBR, high voltage reconnect. You see, I actually mentioned that the charge controller prevents overcharging. In a situation whereby the battery is fully charged, and it happened that the appliances are not connected in the system. So for the system to be efficient, the charge controller tends to what? To actually stop anything coming from the solar panel. That is, to stop the current coming from the battery. Because if it allows that to happen, which means the battery will what? Will be overcharged and it will budge, which means the battery will what? Got damaged. So as such, charge controller will what? Stops the current from entering into the system. And then HBR, high voltage reconnect. That is to say, when you are in that mode that the battery is fully charged, and then you intend to connect 1 or 2 appliances, in that material time, the charge controller will be collecting the current and then be sending it to the battery, which means the battery will serve as what? As a fast. It will only send the current to the appliances directly. And then we have LVD, low voltage disconnect. Low voltage disconnect in a situation whereby you are using your system, and then the intensity is not as bright as possible, and then the load is very, very, very high, which means if the battery is not having sufficient energy, part of the energy coming from the solar panel plus that of the battery will be going to the appliances. So as such, if that situation continue moving that way, which means the battery will be going down small, before you know it, and then the battery will go to an extent at which maybe it will be about to be drained. So charge controller will prevent that. You have to calibrate in the charge controller setting that anyhow, if you are dealing with 12-volt battery, that system voltage, anyhow, if you have, let's say, 11 or 10.9, charge controller just stops everything. So automatically by arriving at 11, it will stop everything, because if you drain your battery to 0 and then you charge it to 100%, you have lose 1 life cycle out of the total life cycle of the battery. So to prevent that, charge controller will automatically disconnect the system. And then we have LVR, low voltage reconnect. Low voltage reconnect, you are in the state of LVD, low voltage disconnect, but all of a sudden you have increase in intensity coming from the sun or maybe from national grid. Current is coming from the national grid, which means it will enhance or exceed or increase the limit of current. Initial current or initial capacity of the battery will also increase. That will make the charge controller to witness, okay, now we are getting improvement away from what we had initially. As such, I will reconnect, even though I am under low voltage, but I will reconnect the energy to the load for the system to work, to continue working. So this is what solar charge controller actually does. And then how many types of solar charge controller do we have? We have about 4 types of solar charge controller. What are they? Number 1, we have pulse width modulation charge controller, PWM. We also have MPPT solar charge controller, maximum power point tracker. We also have series regulator charge controller, and the last one is shunt regulator charge controller. But the aforementioned 2 are widely used. That is to say, PWM and MPPT. That is maximum power point tracker. This is maximum power point tracker charge controller. And you see it has a nameplate. This nameplate contains the information regarding this solar charge controller. That is to say, it is capacity and all it takes. It is 120 amps charge controller. It is net weight. The system voltage 12 volt, 12, 24, 36, 48, which means it can support 12 volt or 24 volt or 36 volt or 48 volt. Meaning it can work with one battery, two battery, three battery, four batteries in series. So, and it has a PB voltage range of minimum of 15 volt and maximum of 170 volt. So, which means in case if you are having an open circuit voltage of, let's say, 50 volt, which means you can be able to connect up to, let's say, 2 or 3 solar panel in series to give us this maximum range. It's only MPPT solar charge controller has this function, whereas which means we can be able to connect as many panel in series in form of strings, because this is 120 amps charge controller, which means if we have like 47 or 37 VOC, which means we can connect up to 4 number in series to form one string. But mind you, connecting panel in series, it means we are increasing the voltage while the current will remain constant. So as such, we're going to maintain the current for a particular solar panel. If we are dealing with 10 amps, which means each string of 4 will have 10 amps. So which means we'll have as many strings as possible, because this is 120 amps. So as such, let's say if we have 10 strings of 4, making we have 40 number panels, and each is producing 10 amps. 10 times 10 is 100, which means we will get 100 amps, which means we'll still have room for what? Additional expansion where we can stop there. But it's only this MPPT solar charge controller has this function. Then we have PWM solar charge controller. I will drop this one. We have PWM solar charge controller. This is PWM solar charge controller. Pulse width modulation charge controller is very small. And this solar charge controller is used for a smaller application. If you notice here, it also has a nameplate. The nameplate, this is 30 volts. You can see 30 amps, sorry. And then it supports 12 to 24. So which means it can only carry 1 battery or 2 batteries in series. And then the maximum capacity of this solar charge controller is 30 amps. So this is PWM solar charge controller. And if it only supports system voltage, whereas the MPPT support system voltage and maximum PB range, which means MPPT is always better than using PWM solar charge controller. As I mentioned, we only have MPPT, PWM that are widely used, but we still have solar regulator, series regulator, and shunt regulator solar charge controllers. So in our next class, we are going to see the interconnection. Why do we apply this MPPT? At what range? How do we connect them? If in case we have smaller capacity charge controller, how do we